my slide here. So as far as our industrial work goes, we created the Midwest Industrial Initiative as a resource to connect industrials with local and national energy efficiency information and contacts. It's a regional network for state, local, and utility efficiency programs and professionals. Basically what we're trying to do with this is link up industrials with policy and program best practices so that they can make additional, more informed decisions about the advantages of installing energy efficiency technologies and processes. And that lists our website up there. And just a reminder for everybody, the webinar will be posted at midwestindustrial.org/resources/webinars. And we will include that in a follow-up email after that link in a follow-up email after the webinar. A little bit more information on that website. It includes a catalog of regional gas and electric utilities with information on their programs, including live contact information, program overview, and links. We also have a catalog of industrial case studies in the region, a catalog of industrial best practices, and a catalog of industrial policies by state. And we also coordinate all of that stuff with the DOE, the EPA, and other state and local initiatives. We also have our Twitter listed up there. If anybody would like to follow us, we try and keep that up to date with what's happening in the industry. Obviously, the WRI paper and Pulp report is today. The webinar is today, but in looking towards the future, we'll be doing a webinar with Mitsubishi on their manufacturing facility improvements, as well as Baltimore Gas and Electric on their CHP program. Just a couple of reminders. Again, you can submit questions in the chat box on the right panel, and I will be moderating a question and answer session right after the presentation is complete. And again, that is the web link to access the presentation, and that should be up within 48 hours of the presentation ending, both the slide deck and the recording of the webinar. And with that, I am going to push this over to Nate Aden and James Bradbury from the World Resources Institute. Nate, are you there?
We seem to have lost Nate.
Thank you, Chelsea. Can you hear me?
Yep.
Yes.
And I can see your screen, so you can just go ahead and get started there.
Okay. Well, first of all, thank you so much for Chelsea Lamar for her help on setting up this webinar, and for Mia for hosting it. We're really pleased with the opportunity and glad that the timing worked out. My colleague James Bradbury and I will be presenting a report that we just published on Monday of this week, and the purpose of this webinar is to give a high-level overview of the report and then hopefully have a little bit more discussion afterwards. And so for that discussion, we've got three great panelists who I'd like to thank for joining us. The first panelist will be William Butch Johnson. He's the CEO of Flambeau River Papers, which is a mill located in Park Falls, Wisconsin. The second panelist is Peter Klein. He's the Vice President of Finance for the St. Paul, Minnesota Port Authority, and he'll be the second panelist talking about their trillion BTU loan program. And then finally we have Mr. Walt Tonneson from Energy Star. He's the Energy Star National Program Manager at the U.S. EPA. So thanks to all the panelists, and thanks to everyone for joining the webinar today. As you can see in our first slide, our subject for this report is energy efficiency in Midwest pulp and paper mills. And the way that we're going to do the overview of the report is that my colleague James Bradbury will give an overview of he'll give an introduction to the report, and then I'll describe sort of the main analytical contents, and then I'll switch it back to James for a review of barriers to energy efficiency investment and policy recommendations that we have in the report. So this slide just shows some of the, well actually I'll switch it to James now to give an introduction. Are you there, James?
Great, thanks. Yep, I'm here. Can people hear me?
Yep.
Okay, great. Thanks, Nate, and thanks everyone for joining. So the key questions we sought to answer with this report are listed here. First, we really wanted to get an understanding of where Midwest mills stand compared to other mills in the country in terms of their energy intensity and emissions intensity. The next key question is, what is the efficiency potential and in terms of the costs that could be saved, and then also the emissions benefits of realizing that efficiency potential. Next question is, what are the most cost-effective energy cost-effective energy and emission saving technology options? So we did, this was really based on the literature review, but also on quantitative and a qualitative look at the available efficiency options. And next we looked at the, let me see, then in the last we looked at the primary barriers to energy efficiency and the potential for policy solutions. So go to the next slide. So the background, so for today's presentation, I already went through the questions, and then Nate will start with a bit of background. We'll go through a benchmarking and emissions inventory that we conducted based on mill-level data from Fisher International database, and also the greenhouse gas emissions inventory from that. We looked at the energy efficiency options, as I mentioned, quantitatively and qualitatively, and then the next part is case studies, which really present the business case to demonstrate why these efficiency options are viable and illustrate the role of policy. And then we finish with the policy landscape and a series of recommendations.
Great. Thank you, James, for that introduction. So I think probably the first two basic questions with this report that we get most often is why the Midwest and why pulp and paper? And so in terms of why the Midwest census region, which is 12 states, stretching from the Dakotas over to Ohio, is the area of the U.S. with the highest industry share of GDP. So industry and manufacturing is clearly very important in the Midwest. It's also a very important area for developing new models for how industry and manufacturing can change to account for new energy and environment situations, new climate situations. And so we really have been focusing there for a little while. Last year, the World Resources Institute published a working paper that looks at energy efficiency policies and the data that are available for industrial energy use among Midwest states. And that was following up on an earlier paper looking at emissions among different Midwest states. Those publications are available through the WRI website. In terms of why pulp and paper, it's clearly a very energy and emissions intensive subsector. In fact, it's the third largest energy using manufacturing subsector in the U.S. Moreover, it's one of the energy intensive sectors where data are actually available. James mentioned that we worked with Fisher International. It's a company that collects and maintains data on all of the pulp and paper mills in the U.S., and so that was a great source for us to do this analysis. Finally, pulp and paper is an industry with footprints in all regions of the U.S. as well as other countries, and so we felt like this was a good starting point for this type of analysis for understanding where manufacturing is going in the U.S. and elsewhere. So this map shows the location of pulp and paper mills in the Midwest, and I should note that the base year for this study and for the report was 2010 because that's a year when data are fairly widely available, and it's also a year that coincides with the new Department of Energy Manufacturing Energy Consumption Survey data, and so we wanted to line up with that in order to have as much analysis as possible. This map shows the location of mills in 2010, and it shows two different types of information in addition to the actual location. One is the amount of production in 2010, and so that's the size of each circle. And you can see that the largest circles are from 500,000 to more than 1 million tons per year for that particular facility. And then the color of the circle indicates when that facility was built or when it was founded. You can see that the oldest mills stretch all the way back to 1882 in the Midwest. Overall, the average age of Midwest pulp and paper mills is 1922, which is a little bit older than the U.S. average of 1937. So that's one interesting difference that we found here. Actually, I'll just, so the purpose of this slide is just to give an overview of the pulp and paper manufacturing process. It's a complex process with a lot of sub-steps, and there's a big range of mills that varies according to production mix, location, the year that the mill was built, the types of equipment that they have in use, and the management practices that they have in use in terms of whether they're using energy management. This figure has two purposes. One is to show to map the basic processes and ways that paper is made. And so you can see in the upper left there's mechanical pulping, and then below that there's chemical pulping. So these are two basic ways to take wood and turn it into pulp that's turned into paper. The third option here is recycled pulp. So taking, recycling is pretty straightforward there. After the pulp is made, then there's bleaching and chemical preparation, and then on the right side of the figure you can see paper making. And so in addition to mapping out the basic processes of pulp and paper making, this figure, and unfortunately it may be hard to see all of the text on some screens, and actually a two-page spread version of this figure is available in our report. The figure also shows the energy intensity that is related to the best available technologies for each of these sub-process steps. And those data are actually from a report published in 2006 called the Pulp and Paper Bandwidth Study that was commissioned by the Department of Energy. And so what you can see with those numbers under each process is the final energy intensity of these processes using the best available technologies. And so the first number with the flame is direct combustion of fuel in the facility. The second one is steam combustion, and the little lightning bolt is electricity consumption. So in terms of the questions that James opened with that we were trying to answer with this report, the basic approach that we took was benchmarking and creating an inventory of all of the greenhouse gas emissions related to pulp and paper mills in the Midwest. There are a number of known issues with benchmarking, namely defining the product or sector, the methods that you use for calculating and the boundaries that you use for calculating, the units that you use for normalization, the level of ambition for the benchmarking, and finally the data sources. So there's a lot of problems that go into benchmarking that we had to address. The usual simplistic approach to benchmarking is just to put entire sectors together and say, well, the average intensity is this, and it'd be great if all the mills could move to the average intensity. This approach doesn't work with pulp and paper because you've got a range of products from tissue paper to cardboard to coated paper, all kinds of products. And you've also got those different production routes that I showed in the earlier figure. So this figure here shows the range of intensities that we found among the different Midwest mills, but like I said, it's really apples and oranges in terms of showing a lot of different types of production methods together in one. And so this was an approach that we had to go around, and we had to figure out a way to address the large diversity of production methods for pulp and paper production in the U.S. So the way that we did that was we obtained data on all of the pulp and paper mills in the Midwest from Fisher International, and we use those data in a spreadsheet tool that's developed by the EPA Energy Star program called the Energy Performance Indicators tool. And the EPI tool, Energy Performance Indicators tool, was developed by the Energy Star program based on census data that account for all of the different facilities throughout the U.S. And the purpose of the tool is to separate out facilities by their production method and by the product mix. So you have more of an apples-to-apples comparison. And so these EPI tools have been developed for pulp mills and integrated paper mills. So they're not available for paper-only mills. And so we used those publicly available EPI tools to assess the pulp mills and integrated pulp and paper mills in the Midwest. And this figure shows the results of that assessment. So the way that the EPI tool works is that a given facility enters its location, and then it also enters the production amount per year for that facility in terms of different production mix, whether it's coated paper or tissue paper or cardboard or etc. And it also enters the amount of energy purchased at that facility for final energy use at that facility. And once it has those data, the EPI tool gives 3 results. The first result is a normalized EPS score, which is between 0 and 100, where a 50 is the normalized score that's given to a facility that has that type of production and that type of product mix within the U.S. that's average performance. So average performance is given a score of 50, an EPS, energy performance score of 50. Facilities that reach the Energy Star efficiency benchmark are given a score of 75. So we ran all of the eligible mills, that's 25 mills in the Midwest, through the EPI tool, and the average unweighted EPS for the Midwest pulp and paper mills was 46, so slightly below the U.S. average. In addition to assigning an EPS for the mill that you're assessing, the EPI tool also gives 2 other pieces of information. One is how much energy would be consumed if it was an EPS of 50, so that's if it was a U.S. average mill. And the second is how much energy would be consumed if it had an EPS of 75, that is, if it reached the Energy Star efficiency benchmark. And so this slide shows the amount of energy that would be saved if the 16 mills that are below an energy performance score of 50 improve their performance so that they were given an energy performance score of 50. And so you can see the green area in the figure here is equivalent to 18 trillion BTU of energy savings, which in 2010 Midwest average energy prices was worth $120 million. If all of the mills in the Midwest that are below an EPS of 75, that is the 21 of 25 mills, improve their performance to that EPS of 75 level, the energy savings would double. So you'd have an additional 18 trillion BTU of energy savings, and that would be worth a total of $240 million per year in annual energy cost savings. So this is one of the core findings of our report. And it shows that there's really a lot of potential for increased energy efficiency among these mills assessed against currently available technologies. And so you can see there are some mills in the Midwest that are at this level. These 4 mills up here in the upper right of the figure here. And those mills are showing that this is really possible and that these savings can be achieved. So this table, oops, overshot. Okay, so this table shows a state level breakdown of the EPS savings that were shown in the previous table. And so you can see that among the 4 states that have mills that have an EPS below 75, the state with the most potential savings is actually Michigan. And so you can see in the 3rd line of the figure of the table here, Michigan has 4 mills that have an average EPS of 20, and they could save 13 trillion BTU per year if they improve their performance to that EPS of 75, and that would be worth $84 million per year. The state with the next largest savings potential is Minnesota, and we can go into more detail later if there's interest in this. Here we go. As James mentioned, the other aspect of our analysis for the quantitative analysis here was to do an emissions inventory of these mills and their emissions in 2010. And so we used a tool developed by Nikasi, which is a group that's related to the paper and forest products industry in the U.S. And we calculated 3 scopes of emissions. One is the direct emissions, and so that's the area in red on the figure here. And those are the CO2 emissions related to combustion in the facility itself. So actually burning fuels and burning natural gas or electricity. And so the yellow area above that is indirect emissions, which is related to electricity consumption and the amount of CO2 required to generate that electricity off-site. Then the third scope is including biogenic emissions, which are the emissions from combustion of wood byproducts such as black liquor at the facility. And so there is some discussion about how to do the emissions accounting for biogenic emissions, particularly at pulp and paper mills, since obviously trees do sequester CO2 when they're growing. The question is how you account for the emissions that result from burning biogenic materials. And so EPA had scheduled for a 3-year deferral and study of this issue, but District Court in Washington, D.C. recently rejected the EPA's request to have a 3-year deferral, and so this is an issue that will be addressed in the near future. And so for our study, we stuck with direct and indirect emissions. We did not include biogenic emissions in our results or our analysis. One thing to note here is that biofueled, that on-site energy is 65% from biofuel and from byproducts of trees, and so it is a very large component of overall U.S. pulp and paper energy use, but the Midwest is a little bit more fossil fuel intensive than the rest of the country, so it varies somewhat. One of our questions in looking at emissions was, what's the impact of energy efficiency versus fuel switching? Because obviously with low natural gas prices, a lot of facilities are thinking about trying to increase their use of natural gas. And so what this figure shows is our simple analysis of scenarios here. And so what we did was we took the 25 mills for which we had EPI data that I described above. Only 7 of those 25 mills actually use coal or oil on site. So the rest of them have already reduced or just never did use coal or oil on site. So among those 7 mills, if they took all of their coal and oil use and switched it to natural gas, it would reduce their total emissions by 19%. If instead of doing that, they took their facilities and improved them so that they reached the Energy Star level of performance, they would reduce their energy use by 34% and their emissions by 34%. So this just shows that the energy efficiency potential here has large emissions reduction potential as well. These are shown separately for analytical purposes, but obviously it's great if they can both happen at the same time. That is, efficiency and fuel switching are by no means exclusive, and in fact, it's great if they go together. So for the third section of this report, we have a review of the energy efficiency options for pulp and paper mills to actually reduce their energy use. And one of the biggest ones, which is illustrated in this photo, is recycling of fiber and recycling of paper. That's a very effective option, and it's relatively cheap. This figure shows the cost curve that we've developed of the energy efficiency and energy savings energy savings options for pulp and paper mills throughout the U.S. And so whereas our benchmarking analysis was a bottom-up analysis based on mill data, this is a top-down analysis based on the U.S. overall. The vertical axis shows the final cost of conserved energy in dollars per million BTU, and this is 2010 dollars for each of these particular measures. And the horizontal axis shows the amount of cumulative final saved energy. And so this is based on, like I said, the US overall. And I'll just point out briefly that the largest measures are shown with the big x-axis or horizontal axis extent. And so increased use of recycled paper in the middle and steam trap maintenance are two of the most effective measures for reducing energy use. And then you can see off to the right there's some more costly measures that can also reduce energy use. What this figure shows is that a quarter of energy can be saved at less than the cost for energy for the average Midwest pulp and paper mill in 2010, and that cost was $6.69 per million BTU. We're running short on time, so I will go through this fairly quickly, but this is just the specific information for some of those measures, and you can see that recycling and drying technologies have the largest savings potential there. So finally, in the fourth section of our report, or of this presentation, we have case studies of plants that have been able to successfully invest in these energy efficiency technologies. And so this photo on the upper left is of the Flambeau River Papers mill, and as I mentioned, one of our panelists will be describing that. And then we also have International Paper, which is a leading company in the area of energy efficiency and environmental accountability. So this table shows an overview of the 6 case studies that we looked at in our report. I know it has too much text for most of the webinar participants to participate in, or to read, but basically we looked at a number of facilities. Flambeau will be described later, so I'm not going to go into that. One facility that I would like to highlight is the Weyerhaeuser Nippon Paper facility. It's called NORPAC, and it's in Longview, Wisconsin. Longview, Washington. Sorry. What's notable about that facility? So they made a large investment in their thermomechanical pulping unit to reduce their electricity demand, and what's notable is that they were able to collaborate with their local utility, which is the Bonneville Power Administration, to really make that investment happen and to allow the benefits of the investment to be shared. And so this is one of the stories that we take away from the case studies, is that manufacturer, and particularly mill or company, collaboration with utilities and efficiency programs can really help to make these investments happen and overcome the barriers that are associated with them. Just in general, the 3 sort of larger benefits that we see with efficiency investments, and particularly in the case studies, is first the jobs benefit, in that these investments can allow the facilities to successfully compete and to stay around or emerge from bankruptcy, and so obviously that preserves the jobs associated with these facilities. In the US, there are 350,000 jobs associated with the pulp and paper sector, and so this is one way to help preserve those jobs. A second benefit is just the overall economic benefit of reducing energy costs and improving competitiveness. And then finally, there are the excuse me, the energy and environmental benefits of reduced energy demand and reduced greenhouse gas and other emissions. So now I'm going to turn it back to James for a discussion of barriers and policy recommendations.
Great, thanks, Nate. So the moment you've all been waiting for, the policy implications of our study. I'll be going through first a little bit of background, or I guess the landscape for policy, the policies at the federal and state level that affect this sector, and then also the our recommendations and final conclusions for this study. So first, a bit on barriers. This is a pretty well-worn ground. There's been a lot of many studies and reports and anecdotal evidence that there are a couple really key barriers to energy efficiency. Everybody asks, well, if this is so cost effective, why aren't people doing it? One, of course, is in some cases transaction cost is often cited, particularly for combined heat and power investments. Pulp and paper sector is actually among the biggest users of combined heat and power technologies because they have such a high steam or thermal load on site. They generate a lot of their own electricity and then use the waste heat for their processes. In fact, I think of the electricity that's generated on site, something like 97% of that is used for CHP. But they purchase another 35%, I should say, of their electricity needs. They meet 65% of that through on-site generation. So what that suggests is that certainly more on-site generation could happen of electricity with better arrangements with utilities for feeding up excess electricity back to the grid. So that's the transaction cost barrier. Capital constraints is always an issue for energy-intensive industries in general, because these are also very capital-intensive industries, and any investment in a facility is a very major capital investment. So that's an important constraint. Getting that money up front usually comes out of an annual capital budget and not typically from big loans, although there are exceptions. And then incomplete information is really just nobody has perfect information, even on the facilities that they own and run. And so there's always a bit more that can be done to improve the level of understanding of where energy is used, where efficiency opportunities might be, and what sort of technologies can help make things run more efficiently. So those are the barriers in a nutshell. Just in terms of the federal policy landscape, there are a number of I guess, laws to point to. First, of course, the Clean Air Act, the Clean Water Act. These are landmark federal environmental laws to provide for air quality and good water quality. The Boiler-Mac rule was recently finalized by the EPA, which is the most recent rule to really impact the pulp and paper sector. That's to reduce toxic air emissions from this and other sectors that have industrial and commercial boilers. It was a significant piece of regulation with significant cost to this sector, but important, of course. This sector is one of the biggest contributors to toxic air emissions, particularly in states, of course, that have a lot of pulp and paper, like Wisconsin. The next point is PURPA, the Public Utility Regulatory Policies Act. Sorry, that's a typo. That it was really a critical act to, I guess, encourage and incentivize the use of combined heat and power at industrial facilities. And in the Energy Policy Act of 2005, actually repealed a key component of that act. And so the incentives that were once there, the regulatory framework for investments in CHP are not what they used to be. So finding a new way to encourage CHP is something a lot of people are looking at. And we'll get back to that. Wanted to, of course, also point out the President's U.S. Climate Action Plan, which was announced just last month. This was a sweeping and important announcement and plan that was put forward in terms of the implications for this sector. In this report, energy efficiency was highlighted as one of the most important areas for achieving emissions reductions in the near term, and of course also one of the most cost-effective opportunities for the economy. So that's, of course, where that intersects with what we're discussing here today. The White House also issued an executive order in August of last year to accelerate investment in industrial efficiency and achieve greater deployment of combined heat and power, CHP in particular. Also, I would like to highlight that there are a number of different federal programs to incentivize investments in industrial facilities and provide technical assistance, regulatory assistance, and financial assistance, whether that's with the Department of Energy, also, of course, the EPA, the National Institute of Standards and Technology, that's the MEP, the Manufacturing Extension Partnership, And these, of course, are all complementary to the items above, the Climate Action Plan and Executive Order. And then, of course, there's legislation. We're waiting, I guess, and eagerly waiting the Senate to take up the Shaheen-Portman bill, which does have provisions for industrial energy efficiency that could help move the ball. There also is recently authorized a recent study which the DOE is doing on barriers and solutions to energy efficiency in the manufacturing sector in particular. And the state policy landscape, particularly as we wait for, I should say the state policy landscape is also very important in terms of administering and implementing some of these technical, regulatory, and financial assistance that's sort of housed within these broader programs at the federal level. And certainly any major manufacturing state has universities and so forth who are engaged in these important state and local activities. State level, of course, also is where utility regulation over rates, retail rates, and grid access is governed. So when it comes to combined heat and power, for example, and connecting these electricity generation units to the grid and feeding back excess electricity to the grid, that's all within the purview of state government, particularly now that PURPA isn't what it once was. The final point, of course, is a lot of states now have energy efficiency targets and goals, which a lot of times these programs are ratepayer funded and implemented by utilities or public benefits organizations, and the industrial sector oftentimes has very significant opportunities for efficiency, and we're actually doing our next study in this sphere is focused on those types of programs, which ones work best and are most cost effective for industry. Okay, the next slide. Okay, so I'll move, sorry, that last slide, it took a little longer than I wanted, so I'll move quickly through this. So policy recommendations first, as of course we've done with this study, is we recommend that the benchmarking of industrial energy efficiency performance. I think it's an important way to understand the distribution of energy use and energy intensity across or among sectors, understand where the efficiency opportunities might be and what types of policy or otherwise types of support could help enable those efficiency investments. We also recommend, I guess, in line with that, a mix of minimum standards, so you can have technical standards and also regulatory standards for new equipment, whether they're motors or compressors, which are big energy users at manufacturing facilities that can help when new facilities are built or upgraded to make sure they're using efficient equipment. And then putting in reach incentives for facilities and operations that are maybe at the top end of the curve. They're higher performing, but they're eager to do more, and with the right incentives, they can do that. Support CHP utilization through federal and state policies. I touched on this before in the landscape. There's essentially what comes after PURPA and what can be done to make sure that CHP is utilized to its full technical and economic potential. A lot of people are scratching their head on this issue now, and it's a bit more of an open question. But we know what a lot of the barriers are, and the trick is figuring out the right solution. The last couple points here is, I guess they're really related to one another. Develop new regulatory frameworks to promote electric utility and manufacturer collaboration. Or I should say this one is very much related to the previous one. Really need to find new regulatory models and policy frameworks that are amenable to the utilities and work for utilities, but also serve the interest of the customers in industry, but also other customers as well. And because, of course, when less energy is used, demand goes down, and that keeps rates lower for everyone. And the final point is, build on this research. We would recommend more studies of this sort for other energy-intensive sectors to really get a better handle on where energy is used by which sectors, and where to really help identify which policies can work the best to seize the cost-effective efficiency opportunities and help drive emissions down across the country in a way that recognizes the regional differences and technical challenges of these sectors, and that's a big reason why we wanted to do this study. And so for key findings and conclusions, energy efficiency can help save the jobs in this sector and other sectors as well. Also, more energy efficient pulp and paper mills we found would save millions of dollars in energy costs, over 100 million, up to 200 million, while also cutting pollution, carbon emissions in particular. And the situation among these mills really reflects the choices facing energy-intensive manufacturers throughout the U.S. For reasons I described, I think, in the previous slide. And there's a lot that I think new corporate policies and government policies can do to lower the hurdles that are preventing companies from realizing these available cost savings and emissions reductions, whether that's incentives or regulations that make sure that new equipment is as efficient as it can be. There's really a suite of options that need to be considered. So I think we're going to go to the panel now. And sorry if I went on too much, but I hope it's useful to all of you.
Great. Thank you so much, James. That was great. And we can circle back to the policy discussion with any questions from the audience, and we will also touch on it with our panelists. Again, the way we're going to do this is we're going to have 3 panelists. The first one is Butch Johnson and his colleagues from Flambeau River Papers, and they will give a presentation on their facility and what has happened recently there. So let me just bring that up. And by the way, the presentation that James and I just gave is available on SlideShare, which is a presentation sharing website, and the full report is available at the WRI website. So I'm hoping that everyone can see the Flambeau presentation now. And Butch and Bill and Randy, are you guys online?
We're all set.
Great, thank you. It's all you now.
Okay, thank you very much for inviting us. Just to give a real quick background, Flambeau River Papers, I purchased in 2006 out of bankruptcy. One of the main reasons that the paper mill went bankrupt was natural gas prices soared to about $14 a decatherm, and that had a devastating effect on the paper mill. We're a small paper mill located in north central Wisconsin. We produce about 155,000 tons of printing and writing paper a year. And the purpose of the first slide is just to show, and I know it's hard to read, but to show the impact that a paper mill our size has on the region. You can see that we hired the University of Minnesota Duluth School of Business to do that study. We had no influence on the results, but it showed about a $300 million impact to the region per year. So unfortunately, we see way too many paper mills closing down all across the country. Here in our region, in the 6 years that I've had the paper mill, or 7 years, we've seen 7 paper mills close down in our region. The next slide is just to further show the impact that we have. And so again, hard to read, but what it does show is the amount of impact on the jobs, benefits, withholding, property taxes, city sewer and water, other products that we buy locally. And in the 6 years, or actually 6.5 years, just those categories accounted for a little over $625 million. When you look at the wages over that period of time, it's with the benefits, it's about $22 million a year. Little town of 2,800 people, we have a large impact, and that doesn't take into effect the loggers that we contract with for our biomass and our white birch that we use in our pulp making process. Okay, go to the next slide. What you can see is how we looked at our fuel costs, and one of our main goals that we first started here was to try to get to have our facility when we were going to have at one time a biorefinery. We thought that we could get our emissions per ton of paper down to just about 0. So understanding what put the paper mill out of business back in 2006, we took on 2 things. Number one, we worked with our workforce and paid them the same wages and benefits that they had previously. We work with the United Steelworkers Union and have a good relationship. We improved upon our productivity by working with our people, and because this is about energy efficiency, we've listed for you where we've gone on our costs since 1999 on our fuel, and what we look at is our CO2 emitted on paper per ton. You can see at one time it was a high of about 1 ton for every ton of paper produced. We got down as low as 33 percent per ton of paper, and the last 2 years we went up a little bit because we had to shut down our biomass boiler for some needed repairs. But that's a number we felt very important. Next slide. Next slide just sort of shows the total energy demand that we have here in at Flambeau River Paper. You can see that that we believe exactly what the study was saying in regards that energy efficiency plays a vital role in keeping our doors open. So you can see what we've done for megawatts of electricity. You can see the decatherms for steam, and then it'll show our total energy. And we've considered that we've done a pretty good job on that aspect. I think the biggest thing that we look at is the challenges that we have, and the idea and the theme that more energy consumption or conservation can be done to further reduce our costs, we'll absolutely agree with. Easier said than done, especially for a small privately held company like ours that's struggling in a pretty darn tough industry that's very capital intense. So I think what we'll just flip to the next page because I know we're under a little time here. We right now are, I think somewhere, we don't belong to the Energy Star program. We belong to a program that DOE has put together called Better Buildings, Better Plants. And our goal in joining them a number of years back was that we would reduce our energy costs by 25% over a 10-year period. We've reduced our cost, I'm going to use rough numbers, approximately 17%. If you take the energy saving programs that we have right here, that would give us another roughly 9 or 10%, and we could achieve those goals. Some of the, on the right-hand side, you'll notice that the simple payback that we calculated with gives the amount of time to recapture our dollars. The problem is it's a $9.5 million investment, but it would save us a little over $2,700,000. That's a pretty good sized number because in our cost of making our paper, that would reduce our cost by about another $18 a ton. A significant savings, and when it comes to selling paper, it's all about dollars and cents because a lot of the products that we sell are commodity driven. So we look at these numbers very much. We've had our challenges in getting our financing to do many of these projects. We're lucky that we have been able to deal with a company here that our state works with the utilities called Focus on Energy Clean Tech Partners. Since we started our mill, they've helped us write grants for about $1 million, which is very helpful, and they provided financing for us in the tune of about $1.7 million, of which we've paid back, I think, $1.2 million dollars of that. So we have a $500,000 out there that just took over a current project that we initiated with them. So for a small company like ours, finding partnerships within The energy sector is very, very important. We have one engineer on our staff. He's kept very busy, and so having the experience from people like Focus on Energy has been very, very helpful for us. So bottom line is, is that we focus on our energy. We found out the big thing is conservation. Got us our easiest dollars. We've got some other slides that we could have sent in, but didn't, that would show where we've invested those dollars and the payback that we received. So we definitely support the programs at our mill that can reduce our costs and help us out in the future. One of the things I'd like to talk about a little bit later, but we'll wait till then, is where we could spend $9.5 million instead of looking at the cost Boiler Mac is going to cost us for what I consider a relatively small value. But I'll wait till we get on to the questions and answers to go over that. So thank you very much.
Great, thank you very much, Butch. And that was a great overview of the Flambeau experience and where you guys are now. And I'm glad that you mentioned the financing challenges, because our next panelist is Peter Klein. He's the Vice President of Finance for the St. Paul Port Authority, and he will be telling us about the Minnesota Trillion BTU loan program. Peter, are you there?
I am here.
Okay, if you could speak up or speak a little bit more close to the phone, that'd be great.
All right. First, I'd like to thank everybody and thank you specifically for letting me be a panelist. And what I'm going to go through is the Trillion BTU loan program, and basically initially just get into how the St. Paul Port Authority got involved in energy efficiency, provide a couple of examples of our financing, and then show some of the results, or the results to date of our energy efficiency projects. So a few years ago, St. Paul Port Authority was charged with finding a renewable energy source for the Rock 10 facility in St. Paul, which is the biggest paper recycler in Minnesota, maybe even in the Midwest. Their power source was excess steam, or steam line, 5-mile steam line from a coal generating energy plant of Xcel's. And that plant was switched to a natural gas peaking facility, and so it was no longer viable to supply the steam that Rock 10 needed. And so we looked at renewable energy sources for Rock 10, but in the process we also looked at energy efficiency, and during the process Rock 10 invested in energy efficiency measures that actually reduced its consumption of energy by in excess of 20%. And that excess of 20% reduction definitely changed the economics of that facility and made it much more economically viable. We also continued on looking for renewable energy sources for them, and we decided that we would pursue anaerobic digestion, mostly in outstate Minnesota, and then with an agreement with Xcel Energy, we would put the biogas into the natural gas system, and then Xcel would do an offset with Rock 10. To date, we have one anaerobic digester in operation, and that's actually at a paper facility, Liberty Paper in St. Cloud, and we do expect to have 4 or 5 more in operation by 2014. So if we can go to the next slide. There we go. That's fine. What we started, though, for energy efficiency was the Trillion BTU loan program, and it really concentrated on bread and butter energy efficiency projects, lighting, HVAC, again, bread and butter, nothing outrageous. We generally finance projects anywhere from $100,000 to $2.5 million, 100% financing. Generally at 4%, we have reduced the rates in some instances to entice businesses to go for the program. Generally, the payments are to be repaid within 5 years, but we do have amortization terms longer than that. The objective of the program is to have no money needed from the business, so 100% financing, and to have the energy savings to be something greater than that loan repayment. So no money up front and immediate positive cash flow to the business. And in general, we don't take UCCs or second mortgages or firstborn. Next page. So we're going to go through a couple of examples. First example is a office tower, the Alliance Bank building. That one happens to be in St. Paul. We certainly do projects anywhere in Excel service territory of Minnesota, and so we are doing projects in St. Cloud, in Mankato, and Red Wing, all over the state. Next page. So in this one, it was an office tower lighting upgrade, $475,000. We financed that 100%. And then when the Excel rebate came in, that was just a dollar for dollar pay down of the loan. The energy savings was about $7,000 a month, and the monthly loan payment $6,600. So we're saving that building is saving about $500 a month. Well, during the payment, they've actually should have paid off by now, and now they're going to be saving the full $7,000 a month. Next page. The next one is a smaller foundry, and we financed a new electric arc furnace for that facility. Next slide. In this facility, it was a $1.5 million cost. The Excel rebate is about $400,000. We financed $1.5 million, and when the rebate comes in, it'll pay it down again dollar for dollar. No money up front for the business. It's positive monthly cash flow of about $1,000. The furnace that we replaced, somebody would come in at midnight on Sunday, and 8 hours later, the furnace would be ready to go. And with the new furnace, it takes about 20 minutes for the startup. In addition, they've doubled their capacity, and they've, I would say, tripled their workforce. So they were, when we first met with them, it was about 40 employees, and now they're well over 120. So it's been a great job creator, and actually, without that, the 40 existing jobs may not have been around. Next slide. So the Trillion BTU fund has been out there for about 3 years. We've financed about 38 projects, $23 million. We've saved on an annual basis over those 38 projects 135 billion BTUs. We've improved 10 million plus square feet. Retained or created 582 jobs, and created 238 construction jobs. The Flambeau projects of $10 million that were mentioned, that would be a perfect project. I mean, if they were in Minnesota and Excel service territory, I'd be all over trying to convince them to invest in those projects, and we would finance 100% of them. And that concludes my presentation.
Great. Thank you so much, Peter. That was a great overview of the Trillion BTU project. So for our third and final panelist, we will have Walt Tunison. He's the Energy Star National Program Manager at US EPA, and he will be talking about Energy Star for industry and the particular offerings that they have for the pulp and paper sector. Walt, are you there?
I hope so. Can you hear me?
Loud and clear, thanks.
Great. Well, thank you very much for having us, and I'd also like to thank Nate and James for their innovative use of our energy performance indicator tool. Let me give you some quick background about the Energy Star program before I mention what tools and resources we have available for pulp and paper mills. The Energy Star program for industry is a voluntary partnership program that is administered by the US EPA. The Energy Star program, I think probably most of you know from your personal life in terms of working around your computer, or perhaps the last time you bought a refrigerator or a microwave or whatever it may be. But Energy Star has actually worked with industry for nearly 12 years. And what we do is we provide a partnership program that focuses on sharing best practices. We provide energy management guidance. We offer tools that help enhance company energy programs, resources, especially things like communication tools, things that engage employees. And as you learned about today, we develop benchmarking tools and tools that help companies track and evaluate their plant and energy use. And as part of those tools, one of the outcomes of them is the opportunity to gain recognition from Energy Star. And as you are aware from our labeled products, we actually label plants. And in fact, pulp and paper mills can in fact earn Energy Star certification. So you can move on to the next slide. So Energy Star works with approximately 23 different industrial sectors and subsectors. And these sectors range from very energy-intensive industries like pulp and paper, petrochemicals, cement production, to smaller, less energy-intensive industries such as baking and dairy processing. And when we work with an industrial sector, we call it a focus. And essentially what a focus is it's a working group or a committee that we convene of energy managers from that industry. And as part of the focus, we have a set of defined tools that we develop. The first thing that we work with the industry on is developing an energy guide, which is a fairly comprehensive report that looks at existing energy saving measures that have fairly short payback periods that can be implemented today. We have researchers who are experts in energy efficiency develop these reports for us. They are then peer-reviewed by people in the industry, as well as people who are working with the industry. So, for example, we actually worked with Focus on Energy in Wisconsin to develop this guide, since they have done a lot of work in the pulp and paper sector. From there, we begin to look at developing benchmarking tools. The reason why we the reason why we develop energy performance indicators, or which is what we call our benchmarking tools, is that if you want to have an understanding of whether your plant is efficient or not, you need to have some sort of way to judge yourself. And because the Energy Star program has unique access to work with researchers who can use census data, we're able to take existing data that's reported by industry to the U.S. Census, and to use that data to develop sophisticated benchmarking tools that allow people to get a relative measure of their performance against the rest of the industry. We make these tools available for free, and they are developed in such a way that no confidential information is revealed. The idea of these tools is to allow people to get a sense of whether or not their plants are efficient or not. I think for many people, they may have a portfolio of plants. In the case of the company we heard from today, they only have one plant. And particularly for small companies where you don't have a portfolio of plants, it can be very difficult to understand how your plants compare against the industry. So part of what we're trying to, the niche we're trying to fill, is to provide industries with a way of looking at their performance. It may not be the only way to look at performance, but we've seen it to be a very effective way to evaluate your energy performance, and a tool that you can use to then set goals and to get a sense of where you need to go to improve. So that's the primary reason why we actually develop these energy performance indicators, and we work with the industry to develop it. In the case of both the pulp mill EPI and the integrated pulp and paper EPI, we worked for several years with industry representatives to develop the tools. They helped shape the assumptions that went into it, and they tested it, and we received consensus from our industry representatives that the tool was a good tool for gauging performance. The other output of the tool is it does allow plants to determine whether or not they might be eligible for Energy Star certification. As Nate pointed out, we set a benchmark for energy efficiency on our energy performance scale of 1 to 100 at 75. So if a plant does score a 75 or higher, they then become eligible to earn Energy Star certification. So we have some other requirements in order to get Energy Star certification. Since we are EPA, we do require that plants have not had any major environmental compliance issues. And if you pass that screen as well as the 75 or higher, then we will award you the Energy Star plant label. In fact, there are currently in the U.S. There are I think it's about 120 industrial plants that have earned the Energy Star. In addition to these resources, though, there's other general resources I think all plants can benefit from. And certainly having a good energy management program is part of it. What I've seen through my experience with working with the pulp and paper industry is that there's really a range of programs development. I've seen companies that have multiple mills but really don't have a very formalized corporate program. They have some good engineers in various plants, but really haven't taken a comprehensive approach, whereas there's other companies that really have very good energy management programs that really benefit from having a strong corporate network and then good engineers on site. And what we've seen with Energy Star is having a good energy management program, it really can help you sustain those savings. And I noticed that Nate's graphic there had pointed out that steam traps are one of the largest opportunities. Well, that's the kinds of things that energy programs at a plant level should be going at. And we all know that steam traps are going to fail, but if you don't have the people there to make sure that you can reduce your failure rates, you're just going to be continuing to waste energy and money. We also offer some other recognition programs too. Since not everyone can achieve the Energy Star level of certification, it is possible for plants, though, to participate in the Energy Star Challenge for Industry. And that sets a milestone for plants to reduce their energy intensity by 10% or more within a 5-year period of less. And so here you're just benchmarking against yourself. You're not necessarily benchmarking yourself against the rest of the industry. But you can use this tool to help you try to strive to that level of top performance. And of course, as I mentioned at the beginning, Energy Star, what we're really about is trying to encourage companies to become world-class in terms of energy management. We facilitate a lot of networking. We facilitate a lot of benchmarking just in terms of corporate practices. And of course, we do a lot of best practice sharing with other U.S. industries. So if you'd like to learn more about the program, you can read about us at our website. You can go to energystar.gov, and you'll find a lot of information about the program and the different sectors that we work with. So Nate, I think I'll leave it with that since we want to have time for questions.
Great. Thank you so much, Walt, for the excellent overview. That was a great description of the Energy Star resources that are available for pulp and paper mills and other manufacturers in the U.S. So the way we're going to structure this is I'll just ask a couple of quick questions to have some discussion among the panelists, and then we will open it up to webinar participant questions, which can be submitted through the chat box. And those will be moderated by Chelsea after we have our discussion. So the first question I'll ask is actually for Pete. You mentioned that the Flambeau project would be a great candidate for the Trillion BTU program. What do you think, is it possible to scale up the program that you have and to do more energy efficiency financing to have maybe a quadrillion BTU program instead? And what are the main impediments to that kind of scaling up? Obviously, you're just focused on Minnesota, but what do you see as the barriers there?
Well, what I've learned is a trillion is a mighty big number. Only about it. I'm just over 10% of the way there, and so I've got a long ways to go just within Minnesota. But I believe that Wisconsin has programs, or if they don't have them, they should have programs that would provide low-cost financing to these projects. I mean, in the financing of the projects that I have done, the repayment, everybody's on time. There's very little risk in not getting paid back, and we really ought to be coming up with low-cost financing for these industries to improve.
Great, thanks, Pete. The next question will be for Butch and his colleagues from Flambeau River Papers. You mentioned that a lot of mills have been closing recently. It's been a period of struggle and attrition for a lot of pulp and paper facilities. Two questions. One is, what advice would you have for other mills that are facing these challenges, and kind of what lessons can they learn from your experience? And the other question is, how has the Better Buildings, Better Plants program that you mentioned helped you?
Well, I think the first thing is I won't give any advice to other people in the industry, as I'm the new guy on the block. 7 years ago, I was never in a paper mill other than on a tour, so I really earned on the run here. And I think the thing that's good about our industry is, number one, it's a industry that uses a lot of energy, so a lot of focus is put there. I mean, if you look at when we bought the mill to today, our energy costs were right now they're about $17 million a year. We reduced those costs by about 25%. Now you all have to look at where we based our, you base your data off of. We based our data when we did most of our projects off of natural gas price of about $9.50 a decatherm. Well, today that's probably down around somewhere $5 or less. So I mean, it has that type of a volatility. So the thing that we look at is how can we sit and try to avoid that volatility. We do that by having using biomass. It's in our mill, being in the Midwest is one of the things I look at. Our overall steam requirements in the summer is about 195,000 pounds per hour. In the winter time, it jumps up to as high as 225,000 pounds an hour. So just because you're in the Midwest versus the South, you could certainly have a change in what your energy percentages are in the cost of a ton of paper. The other thing that I looked at that you provided was ways of reducing, and one of those ways of reducing costs was by using recycle. We do have a recycle operation in our mill. We also have our own pulping process, so we look at that quite a bit. I didn't quite understand, or never really could tell, when you looked at the measure of what recycle does in reducing your energy costs. Is there any credit given to the cost or to the guys like myself that are making virgin pulp? Because without virgin pulp, you're not going to have any recycle to start with. And so I didn't quite follow how that was taken into consideration.
Yeah.
So those are the questions that I had, and I maybe didn't answer your question quite as well as I could, but I don't think I'm a good enough expert to give my colleagues much advice.
Well, thank you for your answer, Butch. I think it was quite helpful. It's a great question that you asked in terms of the recycling crediting, and it's a complicated question in terms of where you draw the boundaries for the energy that goes into the materials that the facilities are purchasing. The basic idea, though, is that if you weren't recycling this paper, it would end up in a landfill and cause additional emissions. And so from our perspective, maximizing recycling is
well, we buy recycled every day, and I think our industry probably is as good as any industry out there, that we recycle up to 70%.
Great.
So, and then you look at the recycling, and one of our problems is whenever we get into a good recycling mode, all of a sudden the Chinese jump in and they buy up all the recycled paper, and it throws us out of whack on how we can have a good steady business using recycle. So there's a lot of other things that go into it that come into play that you have to use in making good business planning for how you outsource raw materials for the operation.
That's a good point, and certainly we're trying to understand the new dynamics that are coming into play for these mills to remain competitive. So thanks for your answers. I'm aware that we only have 10 minutes left, so I want to open it up and switch it to Chelsea to moderate questions from our webinar participants. Chelsea, you there?
Yeah, I'm here, and thanks to all of our panelists today. I think that was a really helpful presentation and informative. I'll start with a couple of questions about the report. So first question is, energy efficiency potential studies usually estimate technical, economic, as well as achievable potential. Do you want to speak a little bit more to the type of potential analysis you did for the report?
Yeah, that's a great question, and James, you can jump in if you'd like, but I'll start with that one. The EPI tool that Energy Star has developed is based on existing competitive technologies, and so this is looking at technologies that have been deployed in pulp and integrated mills throughout the U.S. already, and so it's looking really at achievable potential. It's not looking at hypothetical or anything else. In terms of the economic costs of particular measures, we didn't have data on the particular, whether a mill, let's say in Wisconsin or Michigan, had a particular type of steam press or like a shoe press or something. So we weren't able to get to that level of data and detail, but we were able to look at the mill overall and how it compares with its peers in terms of its total energy consumption per unit of product for different product mixes. And so this is really looking at sort of existing available technologies and what's out there and deployed.
Okay, great.
If I could just add quickly, this is James. So I mean, I think that in terms of those specific terms of art, it's the Energy Star benchmark tool, and Walt, jump in if you agree. I think it's probably the closest description would be technical potential. It tells you what, with existing technologies, could be achieved, you know, for that mill, because we know that peers have achieved that level. So it's really not an economic assessment. Although there was an economic component to another element of the study, and that was the cost curve, and looking at the available technologies and which of those available technologies could be deployed at less than the cost of energy in the Midwest. So that gave us a bit closer to an economic potential assessment in that sense. And in both cases, we found, you know, 25% reduction in energy use was a potential and reasonable outcome to expect, and that's consistent with. There was a National Academy of Sciences study a couple of years ago. There was also the bandwidth study. It's really the same ballpark of efficiency potential, and some of those other studies have looked at economics as well. Hopefully that's helpful. I don't know if Walt wants to jump in terms of how to use the Energy Star tool in that context.
Well, I would just reiterate that it's not actually the tool itself doesn't provide you any information on what technology you should be using, but as you noted, it's because it's based on actual existing performance data for the industry. When it's showing you the scenario of what an efficient plant is or an average plant, that's based upon the fact that we're observing that level of performance for your product mix, for your plant size, for your energy input, the ones, you know, how much biomass and whatever you're using, that there is a potential for you to achieve a higher level if you're at a lower, scoring lower.
Sure. Okay, great. So the next question is about specific actions to facilitate projects of relatively long payback. I know that we obviously have Peter presenting on some finance solutions, but curious if there are any additional recommendations within your report on implementing projects, more long-term projects.
Do you have any advice here? Yeah, that's a great question. we found that there was generally a 5-year maximum simple payback threshold, and so facilities generally, wanted minimum payback periods. But the facilities that were able to invest in longer-term solutions were really able to reap those benefits eventually. But I think probably Butch and his colleagues from Flambeau are best qualified to answer this question.
Yeah, I think that a good example that we did here is we, on our number 3 paper machine, changed over from a steam drive, which caused us to have higher pressure needs to drive the turbines. We were able to eliminate that, and at the same time, I think that payback to go over to electric drives was about a 6.5-year payback. But the other thing that, besides where we looked at it from the energy saving standpoint, was from a quality and production standpoint. So many of the things and technologies that you can use today also help you on other aspects that contribute back to the payback. And so we looked at some of those projects in a number of ways. We also look at some projects where this mill was built back in the early 1900s, so 1896, I guess. But we look at some things that we use with our sulfite process, a very old process for pulping that, besides the energy paybacks, it also looked at safety aspects, not only for the employees, but for the community when it comes to SO2 emissions and things like that. So we look at it from all aspects, and when we put our teams together in the mill to do that, we have a number of criteria besides just immediate payback that we try to incorporate.
If I could, this is James. I just want to quickly jump in and thank. I want to thank all the panelists. I know I have to wrap up soon, but especially Flambeau and Butch Johnson in particular, has been very generous in sort of sharing this level of detailed information about the kind of changes that they make in the plant, and sharing the cost, the payback information. It's unusual for an industrial, mill manager to give that, sort of open the curtain and let people see what they're doing. And I feel like it's really an excellent public service, and certainly valuable for people to understand what it takes to get these projects done. So I just want to make that point, because it's a very unique thing for listeners who may not be aware of that.
Yep, absolutely.
Hey, James, could I make one comment regarding the financing? This is Walt Tennyson from Energy Star. I think what we see in U.S. industry is there really isn't a strong appetite for projects that typically have payback periods before, longer than 4 years, right? And as Peter Klein pointed out, though, these types of investments in industry are very low risk. They're getting paid back, and this is a time where if we want to see American industry continue on a path towards sustainability, we need to have states and other entities begin to look at ways to provide financing for industry to make these kinds of upgrades. It's not at all, unfortunately, that EPA doesn't have the budget to do this, nor Energy Star, but it's great to see these innovative programs like in Minnesota taking a look at industry, trying to maintain these jobs, these loads, and I think further discussion around ways to encourage that type of long-term capital investment are certainly warranted. Perhaps that's something WRI can continue to shepherd.
If I could just add to that one note, the question that I got to a little bit earlier, you could see that we could save ourselves money, reduce the cost of our manufacturing costs by $18 per ton, which is a big number, versus all of a sudden having to look at investing in our boiler $5 million and up an additional $1 million in operating costs for boiler mac. And what we're talking about is getting rid of about 35 tons of particulate over the course of the year. Now that adds to our manufacturing costs. That makes me come up where I don't know how I'm going to find the capital for the boiler MAC of $5 million that we're anticipating, versus all of a sudden going to what you're talking about, energy conservation, reducing our costs to ensure jobs. And I think that's a question that needs to be debated more. I understand that boiler MAC is passed, and some people who look at that with the emissions, feel pretty good about. But when you sit here and you want to put food on the table for 350 people, plus a logging force, that could be the difference in this mill staying open or not. And I think maybe I'm just seeing it a little bit too open. I think there's probably some other people in our industry that can do that. We're not as lucky as a lot of people in the power, the energy cycle selling electricity, where they can throw in an increase to the Public Service Commission and get averaged 8% a year since I've been here, increases. Shit, my paper prices have gone down since then, and it's a different world. So I'll finish with that.
Thank you, Butch. I think that it's clear that there are ongoing challenges for the pulp and paper sector as well as for the rest of U.S. manufacturing. And so this report is not solving all the challenges, but we're trying to identify some solutions to help manufacturers and other energy-intensive facilities to survive these transitions. There's going to be a lot of changes that are going to happen over the next several years, and Boiler Act has been passed. It's here to stay. It's something that manufacturers will have to learn to comply with, but we're hoping that we can find win-win, cost-effective ways to keep these manufacturers around. So thanks again for everyone for joining, and I want to reiterate James's point that we really appreciate Butch and Bill and Randy joining us from Flambeau and for showing this information and for sharing your perspective. It's been very informative for all of us, and thank you for Peter Klein and Walt Tonnison as well. And finally, thanks again to Mia for organizing this webinar, and we look forward to following up with anyone who'd like to discuss this further or to talk about a report. Thanks again so much, and back to you, Chelsea.
Yeah, thanks everybody. I wish we had a little bit more time. Obviously, we're just scratching the surface on some of these issues. But thanks again to all of the panelists for being here. I know we have quite a few more questions, but we're out of time, so I will try and forward them to who I think is going to be most applicable and maybe get some follow-up going there. Again, the webinar is going to be posted to midwestindustrial.org/resources/webinar. Nate and James's email addresses are up there if anybody wants to follow up directly with them as well. And thanks again, everybody. Hope you have a great rest of your day.
Bye-bye.
Thanks. Bye-bye.